Hello dear students, this is the fifth part of the series Algebraic Identities, and the identities that we are going to learn today are a plus b whole cube equals to a cube plus 3 times of ab into a plus b plus b cube, and a minus b whole cube equals to a cube minus 3ab within brackets a minus b minus b cube. Today, these are our learning objectives. First, we will formulate the sum and difference of cubes using prerequisite knowledge. Secondly, we will expand and evaluate cubes using the formulated identity. And we will factorize the algebraic equations using the identity. So let's start. Let us start with a plus b whole cube. A plus b whole cube means a plus b is getting multiplied 3 times. So we can split or we can express a plus b whole cube as a plus b once into a plus b whole square. So we have expressed a plus b whole cube equals to a plus b into a plus b whole square. Remember, in part 3 we have already done identities a plus b whole square and a minus b whole square. So now a plus b into a plus b whole square is a square plus 2ab plus b square. Now let's use distributive property and multiply the quantities of the second bracket one by one with a and b. First, a into a square plus 2ab plus b square, and then plus b into a square plus 2ab plus b square. A into a square is a cube plus 2ab into a will give us 2a square b. A into b square will be plus ab square. B into a square or a square into b will be a square b plus 2ab into b will be 2ab square, and b into b square will be b cube. Now we have highlighted 2 terms in red and 2 terms in green as these are like terms. As you can see, a square b, ab square, these two can be added. Whereas a cube and b cube, they are in the same color that we had started with. These two cannot be added. So we will have a plus b whole cube equals to a cube 2a square b plus 1a square b plus 3a square b plus 1ab square plus 2ab square. 1 plus 2, 3. So 3ab square plus b cube. Or we can simplify the middle terms to get the identity in a different form as well. So a plus b whole cube equals to a cube, that will remain same. Now from the middle terms, 3a and b can be taken common. 3 is common. In both the terms we have at least one a, so a can also be taken common, and in both the terms at least one b is common, so b can also be taken common. So 3ab is common. From the first term, 3a and b have been taken common, so 1a will remain, and from the second term b will remain. So inside the bracket we'll get a plus b, 3ab into a plus b. So a plus b whole cube can be expressed as a cube plus 3ab into a plus b plus b cube. So this is our identity for a plus b whole cube. You can use any of the two forms. Now similarly, a minus b whole cube is a minus b being multiplied 3 times. So a minus b whole cube can be expressed as a minus b into a minus b whole square. Similarly, a minus b into a minus b whole square is a square minus 2ab plus b square. Using the distributive property, a into a square minus 2ab plus b square, and then minus b into a square minus 2ab plus b square. Now the product, a into a square, a cube, plus into minus. Minus, we have to take care of signs as well, as we have minus sign in this case. Plus into minus, minus 2ab into a will be minus 2a square b, plus into plus, plus a into b square, ab square. minus into plus, minus a square into b, minus a square b. Minus into minus, plus, the sign will change, 2ab into b, 2ab square. Minus into plus, minus b into b square, minus b cube. So now the terms in red and the terms in green, they are like terms, so they can be computed. So we will have a minus b whole cube equals to a cube minus minus plus, but sign will remain minus. 2 plus 1 will be 3, so that is minus 3a square b, plus 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 1ab square plus 2ab square, that is 3ab square, and then finally minus b cube. So a plus b whole cube equals to a cube minus 3a square b plus 3ab square minus b cube. If you can notice, then wherever we have b square, the whole term has become plus, as b had the negative sign, so minus into minus twice will give us the plus sign. Wherever we have odd power for b, the sign is negative, and whenever we have the even power, the sign has changed to plus, as minus into minus has given us plus. We can simplify the middle terms in order to get the identity in a different form. A minus b whole cube equals to a cube. Then from the middle terms, since the first term has negative sign, so minus will be common. 3 is there in both the terms, so 3 is common. At least one a is there in both the terms, so a is also common. And b is also there in both the terms, so b can also be taken common. So minus 3ab will be common. Now from the first term, only a will remain. And from the second term, since we have taken minus sign common, so the sign must be opposite. So the sign will be changed to minus and b will remain. So within the brackets, we'll get a minus b and finally minus b cube. So a minus b whole cube can also be expressed as a cube minus 3ab into a minus b minus b cube. Now let us apply the identities to solve different types of questions. The first type of question is, write the following cubes in expanded form. 2x plus 3y whole cube. This is in the form of a plus b whole cube, where in place of a we have 2x and in place of b we have 3y. Since a plus b whole cube equals to a cube plus 3ab into a plus b cube. Now let's put the respective values in the identity. A cube, that is 2x whole cube, plus 3ab, so we can write 3 into 2x into 3y into a plus b, that is 2x plus 3y, and finally plus b cube, that is plus 3y whole cube. So 2x whole cube, 2 to the 4, 4 to the 8, the numerical value has changed, 2 cube to 8. Now since x is a variable, so x cube will remain as x cube. The difference between 2x whole cube and 8x cube is 2x whole cube means cube is for both 2 and x. Now 8x cube means the cube is only for x. Since x is a variable, so it cannot be changed even after cubing, so it is still x cube, whereas 2 cube has changed to 8. Moving on, plus 3 to the 6, 6 3 the 18. Just multiply the numerical coefficients. X into y, xy. So 18xy into 2x plus 3y plus 3 3 the 9, 9 3 the 27. So 3 cube has changed to 27. Y is a variable, so y cube will remain y cube. Again, the difference between 3y whole cube and 27y cube is, in 3y whole cube, cube is for both 3 and y, whereas in 27y cube, cube is only for y. 27 has already been, 27 is a result of cube of 3. Simplifying further, 8x cube plus 18 to the 36, x into x, x square, and y. So plus 36x square y. Multiplying with 3y, plus into plus plus, 18 3 is a 54, x, then y into y, y square. So 54xy square plus 27y cube. So this is our final answer for this question. Now, similar type of question, 2 by 3p minus 2q whole cube. Now, this is in the form of a minus b whole cube, where in place of A we have 2 by 3p and in place of B we have minus 2q. Since a minus b whole cube equals to a cube minus 3ab into a minus b minus b cube. Now let's put the respective values in the identity. A cube can be expressed as 2 by 3p whole cube minus 3ab, that is minus 3 into 2 by 3p into 2q. A minus b, that is 2 by 3p minus 2q. Finally minus b cube, so minus 2q whole cube. Now 3 here can be cancelled. 3 ones are 3, 3 ones are 3. It has got simplified further. Now let's compute. 2 2s are 4, 4 2s are 8, and 4 3, 3 3s are 9, 9 3s are 27. So 8 by 27, p cube. P is a variable, so cube will remain for p. Minus 2 2s are 4, p into q, p cube. So minus 4pq into 2 by 3p minus 2q. Minus 2 2s are 4, 4 2s are 8, q cube. Q is a variable, so cube will remain for q, minus 8q cube. Simplifying further, 8 by 27 p cube minus into plus minus 4 2s are 8 by 3, the numerical value, p into p, p square q. So minus 8 by 3 p square q. Minus into minus plus 4 2s are 8, the numerical value is 8 plus 8 p q into q, q square. So plus 8pq square and minus 8q cube. So this is our answer for this question. Now the next type of question that can be solved using the identity is evaluate using suitable algebraic identity. So we need to find 104 whole cube. Now since we have a cube here, so we have to use the one of the identities that we have learned in this series. 104 can be expressed as 100 plus 4. So 104 cube can be expressed as 100 plus 4 whole cube. In place of A we have 100 and in place of B we have 4. Since A plus B whole cube equals to A cube plus 3AB into A plus B plus B cube. Now let's put the values in the identity. A cube can be expressed as 100 cube plus 3ab, so 3 into 100 into 4, a plus b, 100 plus 4, and b cube can be expressed as 4 cube. 100 cube, 1 ones are 1, 1 ones are 1, and then we have 2 zeros, so after doing the cube, 2 threes are 6, so after 1 we'll have 6 zeros. So whenever we have zeros at the back, compute only the non-zero numbers. Zeros can be taken care of later. Now 3 ones are 3, 3 fours are 12. Then we have 2 zeros at the back. Then 100 plus 4 cube, 4 fours are 16, 16 fours are 64. We have 10 lakh plus 12 ones are 12. Now 2 plus 2, 4 zeros at the back. Plus 4 12s are 48 and then 2 zeros from 1200 plus 64. Now we simply need to add everything. The addition can be done vertically like this as well. So the final answer will be 1124864 or 11,24,864. So the question is done. Next we have 998 whole cube. So which can be expressed as 1000 minus 2 whole cube. Now this is in the form of a minus b whole cube, where in place of a we have 1000 and in place of b we have 2. Since a minus b whole cube equals to a cube minus 3ab into a minus b minus b cube. Now let's put the values. A cube will be 1000 cube minus 3ab. 3 into 1000 into 2. A minus b 1000 minus 2 minus b cube, so minus 2 cube. So just take care of the non-zero numbers first. 1 ones are 1, 1 ones are 1, and then we have 3 zeros at the back. We are doing the cube of it. So 3 threes are 9. So after 1 we'll have 9 zeros minus 3 ones are 3, 3 twos are 6, and then 3 zeros at the back. So minus 6000 into 1000 minus 2. Minus 2 to the 4, 4 to the 8. Further 1, then 9 zeros, minus 6 1 is 6. Then in both the numbers we have 3 zeros each. So 6 and then 3 plus 3, 6. So 6 zeros. 6 and then 6 zeros. So that is 60 lakh. Minus into minus plus, the sign will change from minus to plus. 6 2s are 12. Then we have 3 zeros at the back of 6000. So 12,000, or 12 and then 3 zeros. Minus 8. Now let's group the numbers in terms of their signs. 100 crore plus 12,000 will be 100 crore 12,000. Minus minus plus, but sign will remain minus. 60 lakh plus 8 will be 60 lakh 8. So on doing the subtraction, we will get 99,401,192. 99 crore 40 lakh 11,992. Looks ominous, but once you get the hold of it, it's quite simple. Next type of question, we need to factorize the following algebraic expressions. The first question is 8a cube plus b cube plus 12a square b plus 6ab square. So as soon as we get such numbers where we have 4 terms and 2 of the numbers look like perfect cubes or which can be cubed, then we have to understand that we need to use the identities that we have learned in this series to factorize the algebraic expression. So let's start. 8a cube can be expressed as 2a whole cube, as 2 to the 4, 4 to the 8. So 8a cube as 2a whole cube. Plus b cube can simply be expressed as plus b whole cube. The two terms, the remaining two terms, will form 3 in ab into a plus b. So 3 into 2a into b within brackets 2a plus b. Now if you will compute this, then definitely we'll get the two terms which are at the back. 3 2s are 6, so 6ab into 2a plus b. Now on further computing, 6ab into 2a, 6 2s are 12, a into a square b. So 12a square b plus 6ab into b, 6ab square. However, we don't need to do this all the time. This was done just for a representative purpose for you to understand. Now, although it's not required, but still some of you may get confused. So let's put the terms in the same order in which we had derived the identities. So a cube first, that is 2a whole cube. Then 3ab into a plus b. So 3 into 2a into b into 2a plus b. And then finally b cube. So now this is in the form of a cube plus 3ab into a plus b plus b cube, which is equals to a plus b whole cube. So this algebraic expression can be factorized as 2a plus b whole cube. So the question is done. Similar type of question, 27p cube minus 1 by 216 minus 9 by 2p square plus 1 by 4p. 27p cube can be expressed as 3p whole cube, as 3 3s are 9, 9 3s are 27. So 27p cube as 3p whole cube. Next we have minus 1 by 216. 1 can simply be expressed as 1 cube. 216 is 6 cube. 6 6 36, 36 6 is 216. So minus 1 by 216 can be expressed as minus 1 by 6 whole cube. So we have got our a cube and b cube, a cube minus b cube. Now minus 3ab will be minus 3 into 3p into 1 by 6, and a minus b will be 3p minus 1 by 6. Now if we will compute, then we will get the last two terms, that is minus 9 by 2p square plus 1 by 4p. However, this is not required. Now let's write the terms in the order. 3p whole cube first, a cube first, minus 3 into 3p into 1 by 6 into 3p minus 1 by 6, 3ab into a minus b, and finally b cube minus 1 by 6 whole cube. This is in the form of a cube minus 3ab into a minus b minus b cube, which is equals to a minus b whole cube. So the given algebraic equation can be factorized as 3p minus 1 by 6 whole cube. So this question is also done. Now these are assignment questions for you which are similar to the ones which we have done in the video. Thank you and have a nice day.